Hey there, science fans! Have you heard about quantum computing? It's not just about faster computers, it's a whole new way of thinking about computing. Imagine a computer so powerful it could solve problems in minutes that would take classical computers billions of years. That's the promise of quantum computing. You see, classical computers use bits, which are like tiny switches that can be either on, which is 1, or off, which is 0. But quantum computers use qubits, which are like super-powered bits. Qubits can be both 0 and 1 at the same time. This is where things get really wild. This mind-bending concept is called superposition, and it's just the tip of the iceberg. Quantum computing is like entering a universe where the rules of the game are completely different. So buckle up and get ready for a wild ride as we explore the fascinating world of quantum computing. Let's talk about the building blocks of this revolutionary technology, qubits. Imagine a regular bit like a coin. It can be heads, which is 1, or tails, which is 0. Now picture a qubit as a spinning coin. Until it stops, it's both heads and tails at the same time. This both-at-once state is called superposition. It's mind-boggling, but it's what gives quantum computers their incredible power. Think of it like being able to explore every path in a maze simultaneously, instead of trying each one after another. But how do we harness this power? That's where things get even more interesting. We'll explore that next. Hold on tight because we're about to dive into entanglement. Imagine two of our spinning coins linked together in a special way. When one lands on heads, the other instantly lands on tails, no matter how far apart they are. This is entanglement. Two qubits so deeply connected that they act as one, even across vast distances. It's like they have their own secret language. This spooky action at a distance, as Einstein called it, is what allows quantum computers to tackle incredibly complex problems. By entangling multiple qubits, we can create a network of interconnected superpowered bits capable of performing calculations that would take classical computers lifetimes. It's like having a team of super geniuses working together on a single problem. So, what makes quantum computers so special? It's their ability to tackle problems that are practically impossible for classical computers to solve. Imagine trying to find a specific grain of sand on a beach. A classical computer would have to examine each grain one by one. But a quantum computer, with its qubits and superposition, could analyze all the grains simultaneously. This massive speed-up opens doors to solving some of humanity's biggest challenges. We're talking about designing life-saving drugs, creating unbreakable encryption, and developing artificial intelligence that can truly think like a human. The possibilities are endless. Okay, enough theory. Let's look at how quantum computing could change our world. So, first up, medicine. Imagine designing personalized medicine tailored to your unique DNA, or simulating complex molecules to develop new drugs and therapies. Quantum computers could really make this a reality. Now, when it comes to artificial intelligence, quantum computers could be used to train AI models much faster and more efficiently, leading to, smarter robots and more powerful machine learning algorithms. And what about finance? Want to make smarter investments? Quantum computers could help analyze financial markets with unprecedented speed and accuracy, identifying trends and predicting risks like never before. Oh, and cryptography. Quantum computers could break the codes we use to protect our online information. But don't worry, they can also create new, unbreakable codes to keep our data safe. And that's just the beginning. From optimizing traffic flow in megacities to designing new materials with unheard-of properties, quantum computing has the potential to revolutionize countless industries. Building a quantum computer is no easy feat. Remember those super-sensitive qubits? They're easily disturbed by their environment. Even the slightest vibration or change in temperature can cause errors. That's why quantum computers need to be kept at extremely cold temperatures, colder than the depths of outer space. We're talking about a fraction of a degree above absolute zero. This supercooled environment helps to maintain the stability of the qubits and allows them to perform their quantum magic. Companies like IBM and Google are leading the charge, building bigger and more stable quantum computers all the time. It's like a race to create the world's most powerful supercooled brain. While quantum computing is incredibly exciting, there are still some hurdles to overcome. One of the biggest challenges is decoherence. Remember how easily disturbed those qubits are? Decoherence is what happens when qubits lose their quantum properties due to interference from their surroundings. It's kinda like trying to write with a pen on a bumpy bus ride. Another challenge is error correction. Because qubits are so sensitive, even tiny errors can snowball into big problems. Scientists are working on clever ways to detect and correct these errors, ensuring that quantum computers can perform reliable calculations. Finally, there's the issue of scale. We need to build quantum computers with many more qubits to solve really complex problems. It's like going from a simple calculator to a supercomputer. But don't worry, scientists are making incredible progress every year. The future of quantum computing is bursting with potential. Just imagine a world where we can, develop new materials that are lighter and stronger than anything we've ever seen, create personalized medicine that targets diseases at the molecular level, design ultra-efficient solar panels that can power entire cities, and even understand the human brain in ways we never thought possible. This might sound like science fiction, but it could become reality sooner than we think. As we continue to unlock the secrets of the quantum world, we open doors to a future limited only by our imagination. So stay curious, my friends, and never stop exploring the wonders of science.